Now rotational spectra and isotopic substitution. The B, we know that it is equals to h upon 8 pi square I c. So B is inversely proportional to I, moment of inertia, and I is equals to mu r square. Therefore B is inversely proportional to mu r square. And if we take r as constant, that is bond length at constant, then it is B is inversely proportional to mu, that is rotational constant is inversely proportional to reduced mass. So whenever an atom is replaced by isotope, bond length does not change, and if bond length does not change, then mu changes. Okay, so that is if we take rotational constant of isotope and rotational constant of normal molecule, if we divide them, then it will be equals to inverse of if we take numerator at isotope, then reduced mass of isotope will be in denominator, and in denominator on the left hand side we have taken B of normal molecule, then reduced mass of normal molecule will be in the numerator, because the B and mu are inversely proportional. So we know that reduced mass of normal molecule is always less than reduced mass of isotopic molecule. So if we take this to the left side, it will go to divide, then mu normal upon mu isotope is always less than 1. Now when this value is less than 1, means this value is less than 1, so this value is less than 1, that is B isotope upon B normal is less than 1. That is, if we multiply B normal to the right side, then we get B isotope is less than B normal, and if we multiply both sides with 2, then 2B isotope is less than 2B normal, which is 2B is what? Separation between the two lines in rotational spectra. So isotopic substitution decreases the separation between two lines. So we have concluded in 2 points that the rotational constant of isotope molecule is always less than the normal molecule, and the separation between the two lines decreases when we place an isotopic substitution we take, then it is always less than the normal molecule. Now for example, for HCl these are the two rotational line, and for DCl these are the two rotational line. Sorry, this gap is less somewhat from this gap, so the gap 2B here is more, because this is normal molecule HCl and this is deuterium, which is isotopic substitution in the place of hydrogen. So this value is somewhat less 2B, because here the B, it is B dash, rotation constant B dash is B. So when B dash is less, therefore 2B dash is less from 2B. Now question, if the B value of HCl is 1 centimeter inverse, what is the B value of DCl? So it can't be 1, because we know that for isotopes B is less. It can't be 2, because 2 is greater than 1, and so there are two possibilities, either 0.8 or 0.5. So for that we have to calculate. We know that B of DCl upon B of HCl, if we divide, then it will be equals to inverse of mu, that is B DCl is numerator, so mu DCl is in the denominator, and B HCl is denominator, so mu HCl is numerator. So this is the formula. Now isotope is DCl and normal is HCl. Now mu is what? Reduced mass, which will be equals to m1 into m2 upon m1 plus m2. m1 is for H, m2 is for Cl. So m1 is 1 into 35.5 of Cl upon 1 plus 35.5, that is 36.5. Similarly, mu of DCl is m1 into m2 upon m1 plus m2. So m1 is for D, m2 is for Cl. D is 2 into 35.5 for Cl divided by 2 plus 35.5. So this one. So the divided sign has been changed to multiplication, and it has been inverse. Simple maths. So on solving this, we will nearly get 1 by 2. So what is 1 by 2? It is 0.5. So the D option 0.5 is correct for the B value of DCl. Now another question, this time the isotope instead of H it is Cl. Here it is BHCl, Cl 35.5 mass, and here 37.5. so now the chlorine is the isotope. So for BHCl normal molecule it is 1 centimeter inverse, and then what is the BHCl for if the chlorine is the isotope? Then we know that B dash we are taking as for isotope. For isotope upon for normal molecule equals to mu of normal molecule upon mu of isotope. So we know that is it is m1 into m2 upon m1 plus m2. So 1 into 35.5 upon 1 plus 35.5 is 36.5. Similarly it is in denominator, so 1 into 37.5 because chlorine mass is 37.5 here because it is isotope, and 1 plus 37.5 is 38.5. so on solving this we get around 0.998. So what we have concluded that B of normal HCl is 1 centimeter inverse and B of isotopic HCl is 0.998. In the previous question we have seen that B of HCl is 1 centimeter inverse, and for deuterium HCl it is 0.5, just reduced to half. It was reduced to half, but here only small difference. So what we have concluded is isotopic substitution decreases the value of V in both the case, but the effect is more whenever lower atom is replaced by heavier isotope. That is, when hydrogen was replaced by deuterium, the effect was more, the difference was more. But when the bigger atom chlorine is replaced by isotope, then the effect is less because the difference is less between 1 and 0.998. Now next question. Now consider the following compounds, arrange them in decreasing order of rotational constant, that is B value. So for that we don't have to worry and calculate by using this formula and putting the mu of all the molecules and then calculating the B values for each and everything, and then arriving at the point that which is greater or which is smaller. It is just a trick how to see which is small or which is greater, the B value. You should just multiply the mass of the both atom. For example, here H is 1, the mass is 1. For bromine it is 81. Here the mass of H is taken as 2 and bromine is 79, and here 1, 79, 2 and 81. Multiply both of them. So what we have arrived some values. So the higher the product of the mass, the lower will be the rotational constant. Therefore for the fourth, 2 into 81 it is 162. So the rotational constant is least in the case of fourth. Then and the rotational constant is largest in case of third 1 into 79 is 79, product is 79, then 81, then 158. So the decreasing order is this rotational constant, third, then 1, then 2, then fourth, because the product is increasing. Okay, mass of product is increasing. So similarly this question, the minimum value of rotational constant B we have to calculate. Following are the options. So what I told you, that the maximum, if there is maximum product of masses of two atoms, then the rotational constant will be least. So in this obviously 15 into 17 will be highest, because here it is 16 oxygen, and here 17, here 14, 15 and 14. So both are isotope in this case. In C case, nitrogen is also isotope, oxygen is also isotope. So the maximum product will come out in this case only. So the minimum value of B will come in this case. Now the rotational constant B is equal to 3 centimeter inverse. This is another question for carbon 12 16O, carbon monoxide. Now the rotational constant for this compound carbon monoxide, where carbon mass is not given, oxygen is 16. So what is the mass of, or what is this isotope, which isotope is this? So we have to calculate the mass x of carbon. So for that we have to calculate by using that formula. B of normal molecule upon B of isotope is equals to mu of isotope upon mu of normal molecule. So B of normal molecule is given as 3 centimeter inverse, and B of isotope is 2.85. So this is mu of isotope, which is m1 into m2 x into 16 upon x plus 16. And this is for isotope, normal molecule.